Hi, my name is Leo Lamb, and this is my project 2 for the Design and Manufacturing course at Georgia Tech. This project requires improving upon a product to solve something that bothers me. I decided to create an improved chopsticks that also acts as a bag clip. Here's the agenda for today. I'll review the project description, the detailed description of my solution, graphics of the concept in the CAD, the materials and manufacturing processes involved with creating the solution, and conclude with pros and cons. Here's the project description. During my internship this summer, I was told a very important piece of information on the first day: where the snack drawer was. Naturally, I found myself there often, snacking throughout the day as I work. However, oftentimes I find myself doing some kind of circus maneuver where I'm using two fingers to eat my Cheetos. The rest of my fingers are moving my mouse with my palm, while my other hand uses the keyboard. I don't want to get my mouse and keyboard dirty from the chip dust, and the nearest sink at work is all the way across the floor. But I also really like food and snacking throughout the workday. I saw online that some people actually use chopsticks to cleanly eat chips, so I tried that, but ran into some inconveniences as well. One of the problems I encountered was, where do I put the chopsticks after I'm done eating the chips or while I'm taking a break from eating and focusing on work? I often have lots of nylon powder at my desk since I tinker with a lot of SLS prototypes, so placing it anywhere on my desk can get dangerous, even on a napkin. Also, since I'm doing a lot of prototype work, I actually start having trouble locating where I put the chopsticks to begin with because there's just so much prototypes on my desk. Furthermore, the tips of chopsticks can become quite difficult to clean, especially if they have these grooves like the picture on the right. Also, if you break a chopstick, you have to buy another pair, since what good is one chopstick? I usually toss my chopsticks in the washing machine, but that seemingly deteriorates a wooden chopstick's lifespan. So what was my solution? I created a chopstick with a detachable, disposable tip. That way you can take it on and off anytime you want. This allows easy replacement, as instead of the entire chopstick breaking, the tip would be most likely to break, and replacing the tip is less costly. For my case, I plan on having a bunch of tips at my desk and put dirty tips in a bag, and then just clean all of the tips at the end of the week instead of after each time I snack. I also wanted a convenient and easily locatable place to put the chopsticks when not in use. I decided to make the chopstick act as a clip that can lock a chip bag close, since I usually don't finish a bag of chips in one sitting. This lets the chips stay as fresh as possible, also while providing a convenient location when the chopsticks aren't in use. And also, the chopstick base or body is able to be put anywhere while on the chip bag without worrying too much about the body getting dirty, since the tips are the part that's important not to get dirty, and those would be detached when the chopstick acts as a chip clip. Here's my design. The left shows the chopstick body, which acts as chip clips when not in use for eating. I used an indent-detent design to secure the two sticks together. The ball on the top of the figure are the indents that go into the bottom extrusions, where there's a detent to accept the balls. On the right are the chopstick tips, which have these prong-like extrusions that are able to flex inwards and insert into the chopstick body. The little balls on the prong enter into the holes at the top of the chopstick body, labeled as chopstick tip insertion hole in the figure 5. Here's a clearer image of how things connect. As you can see, the prongs on the chopstick tips would flex inward to allow it to enter the hole, and once the balls of the prong finds the hole, the elasticity of the material should move the prongs back and lock the chopstick tip. On the right, it shows the indent-detent attachment, with a chamfer added in to make it easier to connect. Here's a little animation showing the chopsticks converting from normal chopstick use to bag clip mode. I also went ahead and 3D printed the design. After many iterations, here's how it turned out. Note the audible cues for when things connect properly. So for the 3D printed chopsticks, here they are. So as you might be able to see, there is the hole for the chopstick end. So I can simply slide this on like that, and then it's quite secure. And then when I'm done, I can just take them off. So to close a chip bag, you simply first snap the indent detent on one side, like that. Take your bag of chips, secure it over it, and then snap the other side on. And as you might be able to hear, that's quite secure. As you can see, it's not going anywhere. And then you simply remove it. So I also went ahead and put some plastic wrap over the chopstick tips because the 3D prints are not food safe. So I'll just quickly show. Grab a chip. And you need it just like that. So what are the manufacturing processes and materials needed for my design? So for my use case, when I return to my internship this summer, I'll be using the model I just showed, which was 3D printed with PLA. However, in order to keep it food safe, as I showed in the video, I'm going to cover all of the tips with plastic wrap to avoid bacteria growth and then reprint it often to avoid any accidental bacteria growth since printing it is so cheap. In a more professional execution, the chopstick tips would preferably be made out of wood, since wooden chopsticks is usually easier to grab things with than other materials. However, if the prongs do not have the flexibility needed with a wooden tip, I'd instead use a plastic tip, and the plastic I'd use would be something like melamine, which are what chopsticks are currently being made with. And then I'd also add a bunch of bumps and ridges to the tip to improve the grip. For the body, I'd use stainless steel since it's easy to clean, light, and durable. The manufacturing processes involved varies for the chopstick tip. If it's wood, sawing and lathing would make the chopstick shape, and then finishing would be applied to make it more durable and food safe. For a plastic version, injection molding would be efficient and cost effective. For the chopstick body, a steel disc created from blanking would be extruded into a tube using a punch. The indents for the chip clip would be soldered on, and the receiving holes for the chopstick tip would simply be drilled. So, in conclusion, my design allows me to easily snack while working without disrupting the flow of work to wash my hands or chopsticks. It's easy to maintain or replace due to the detachable tips, and it's able to close my bag of chips, keeping it as fresh as possible. When it's clipped into the bag, it's also easily locatable. Disadvantages include that the indent receivers can sometimes get in the way while you're using the chopsticks. And also, the chip bag can't be too thick as the tolerances to connect them are quite tight. Why does this product improve upon normal chopsticks? 2 reasons: versatility and longevity. Versatility, the chopsticks are able to seal the bags, there's different tip materials you can use depending on use, and you don't have to wash it every time. Longevity, you can easily replace chopstick heads, and the stainless steel body lasts longer and are easy to clean. Here are my resources for the project. And as a disclaimer, this project was made for educational purposes and does not resemble any existing product or patent to my knowledge.